some exercises about what I did on Monday. Okay. First exercise. Let us consider the problem of classification between two classes, W1 and W2. Remember that on Monday we have seen a course about parametric classification. Parametric classification means parametric classification means we know we have omega 1 is the class 1, omega 2 is the class 2, and px omega 1 is the distribution of data under the class 1. Px omega 2 are the distribution of the data under the class 2. We know the equations this and this. If we know the equations this and this, and we know p omega 1 and the p omega 2, which are the probability of the class 1 and class 2, so p omega 1 over x, so we can estimate, if you have all of these, we can estimate p omega 1 over x and p omega 2 over x, and if we estimate both of them, we can decide if the x is belonging to which class. Okay, and we have seen that in case of two class, we have to apply this ratio, px omega 1 over px omega 2, if less than class 1 and is greater than class 2, or we have seen that we can apply only this equation, px omega 2 over px omega 1, if it is less than this ratio, class 1. If it's greater than, we can say that it's class 2. Okay, so this is what we have seen this equation. So today we will apply this equation. We have this equation as a class 2, we have the equation of the class 1, and we have to apply this equation. Okay, to find for any x coming, if x is belonging to the class 1 or to the class 2. Okay, and we have seen at the end we have seen that if in case of multi-class, yes, here, in case of multi-class, that means if you have m class, not only two, we cannot do the ratio. So you have px omega 1, you have px omega 2, p omega m. So we have to find p omega 1 over x, p omega 2 over x, p omega m over x. If you find all of these data, so x will be classified in the class k, where p omega k over x is maximum. Okay, so you can classify x in the class where p omega x maximum, and this is what we. And how can you estimate p omega a over x? P omega over x is estimated by this value, px omega a p omega over p of x. Px omega, and what is the value of p of x? P of x is px omega 1 omega 1 plus px omega 2 omega 2 plus px omega m p omega. Okay, so this is what we have seen last time. So today we will apply this. Let's go. Today we will do exercises and lab only on this chapter. You have this, I think, in your domain. I will see. We have exercises. So exercise parametric 3. You have it, okay? So I can continue. Okay, this one. So let us consider the problem of classification between two classes, W and W2. I have W and W2, two classes. X is belong to R. So X is belong to R, so that means X is in one dimension. Let us suppose that the probability density function in the class 1 is fx is lambda exponential minus lambda x. This is the equation of the probability under the class 1. So what this means? This means that this is the equation of P. This is P x omega 1. Px omega 1 is this one, okay? Px omega 1, Px omega 1 is this one, okay? Is this equation, Px omega 1. Okay, the class, because the probability density function of the class 1. What this means? This means that Px omega 1. And the distribution of the class 2 is Gaussian m equal 1, sigma 2 equal 9. What this mean? Is Gaussian, that mean P of x omega 2 equal Px over omega 2 equal 1 over radical 2 pi. You know the equation of Gaussian? 1 over radical 2 pi sigma 3 exponential minus x minus m, the mean is 1, minus 1 square over 2 times 9. You see? So when you say class 2, distribution of the class 2 is Gaussian, because here we have seen that Px omega 2 is the distribution of omega 2 is Px omega 2. Distribution of x1 is Px omega 1. So here Px omega 1 is this one, and the Px omega 2 is this one. So the question now, determine lambda and determine the statistical test that correspond to the classification problem. Okay, we have two questions. What is the value of lambda? Lambda is here. What is this value of lambda? And secondly, what is the equation of classification test? Okay, if we want now to apply this, first of all, we have to plot the signal. Okay, if we plot the signal, we will have these things. Okay, if we plot the signal, the first one is exponential. This one is class 1, and the same axis x. Okay, in the same axis x here you have x, and here you have f of x in general. Okay, but the first one, the first curve is for the class 1, p of x class 1, and the second one is p of x in class 2. Okay, so this one is the class 1, and this one is for the class 2. The class 2 is Gaussian of mu2, which is here's the class 1, the class 2. The mean is 1, and this one is coming like that. Okay, go to the infinity. So what is the question is, when you ask the statistical test, what is the best row? This is the question. The best interface that can. So for this you can say class 1. For this you can say class 2. This is the A. But in the class we have seen. Remember, in the class we have seen the case when both are Gaussian. In the class you have seen, look, when both are Gaussian. But here we don't have both Gaussian. Here we have this one is Gaussian, and the second one is what is exponential like that. We have one exponential and one Gaussian. So what is the best threshold? You see? So this is what we are looking for. Great. Let's go. Let's make the solution. Uh, First, determine lambda. In the first chapter, when we did the part of probabilities, remember that the equation of Gauss exponential is lambda exponential minus lambda x. Lambda, you must have lambda here and lambda here. Okay, so here in the word lambda, here you have the equation lambda exponential minus 8x, so lambda must be 8. Okay, lambda here must be 8, so that the surface must be 1. The surface must be 1. Okay, so surface must be 1, so lambda equal 8. Second equation, we have to determine what is the statistical test that corresponds to the classification problem. To find the statistical test, you have to apply the formula because you have only two class. The ratio here, probability here over the probability here is if it is less than P omega 1 omega 2 class 1, otherwise class 2. So we write the equation. We start from here. What is P omega 1 is 0.5. What is P omega 2 is 0.5. Why? Because we know that the probability of the class 1 is P omega 1 half. If the P omega 1 equal half, P omega 2 equal half, because the sum of the both probability is half. Okay?
Okay.
Yeah.
Uh, so P omega equal half, P omega equal half. So the class 2 is Gaussian. Omega 2 Gaussian. M equal 1, sigma 2 equal uh, sorry. If if omega 2 is Gaussian, M equal 1, sigma 2 equal 9. So the Px over omega 2 equal 1 over the equal P 2 pi 3 exponential, as I write to this is the equation of the class 2. و if and the second one, Px omega 1 is 8 exponential minus 8x. So if we apply this formula, so this one is this one, and Px omega 1 is this one. So this over this, if greater than 1 class 2, less than class 1. So we can simplify. You can have 1 over 2 radical 3 P8 here, exponential this plus this, if greater than 1 class 1, less than class 2. And look, if you do log of all of this, you have minus this plus 8, plus 8 log, 8 log plus log, is if it is greater than 0. So here you have a second equation you have an equation with the second class. Okay. So in the computer we can program this. In the computer we can program this equation. In the computer we can program this equation, and we can if any for any coming x, if x minus 1 square over all of this is less than 0 class 1, otherwise class 2, we can find x. Okay, we can find the solution, but it's not necessary for me. Okay, for me it is just I want to understand that you understand. When you put this and you put only this ratio, I know that you understand. Only you have to put this ratio, so I understand. I know that you understand. Okay.
Okay.
Okay, great. Now I will pass to the second exercise, which is more complicated. We wish to make the classification between two classes Gaussian now. Look, now X belong to R3. X belong to R3 of mean M1, 1, 1, 1, two Gaussians, and M2 will 5, 5, 5. Okay, I have in the space, like that, in the space. I have in R3, that means I have X1, X2, and X3. This is 1, 1, 1. And this is 555. So around 111, I have data, Gaussian. Okay. And around, okay, and around here, you have always also got data. Okay, something like that. So around in the space, in the space, not in R2, in the space, around 111 and around 555. Okay, you have 555 is the center here, and 111 is the center here. Okay, the center here is 111. We have 300 in the class 1. In general, we have 300 all total, 100 here, 50, 150 here. So the classification is we have two class, the P omega 1 and the P omega 2 equal half. Every P omega I equal half. Okay? Give the classification test in the following three areas. We need the classification test in case of sigma 1 equals sigma 2 equal I. What does I? I means 1, 0, 0, because we are in R3. 0, 1, 0, and 0, 0, 1. What this mean? This means the variance is 1 and we don't have any covariance. This is I. The matrix I in R3 is this one, because remember in the data probability course, when we say, if you have, for example, if this is the equation of Gaussian, if X belong to RD, this is the equation of the Gaussian distribution, and the sigma in general is d times d, and the values here are, if X equal x1, x2, xn, so sigma is variance, and covariance. N times n. So if you have only x1, x2, x3, so the variance is c times 3. Okay? Look, if you have x, if x only contain x1 and x2, the matrix is 2 times 2. So the matrix always is n times n. The matrix here, if x belong to Rd, sigma is d times d. Always. Sigma is d times d. Okay, so here So here, sigma equal I equal 1, 0, 1, 0, 0, 0. I means one identity. Identity means that 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay?
Okay.
So, and we have to take this second case, and we have to take this third case. Okay? What is this? Here, if you want to plot, you have any question? No? Okay. In the
No.
second case, look what means. Here, if I 111 mean the data are symmetrically distributed around all the data, all the center. Okay? The data are symmetrically distributed. What this means? This means that the data near around the center are symmetric. Here no. Here 4, 2, 2 means what? Means here class 1, you have to divide by the variance. The x is 1 over the variance. Okay, what this means? This means you around x3. This is x3. It's very big. It's very big. So it's ellipsoid, but something like that. Here is 1, and around x1 is 1 over 4. 1 over 4. X1 around x1, and around x2 in the deeper. This is x2 in the deeper. So it is 1 over 2. 1 over 2 in this direction. In this direction, and in this direction, and in this direction. So you can imagine that this is ellipsoid, something like that. Okay, something like that. Okay, and here the same. Here ellipsoid is the same, around 111, the same like that. So we have to find the line or the plane, because we have seen in the class. So if sigma 1 equals sigma 2 equals sigma, okay, the interface is linear, is a line. Today we have to find what is the equation of the line. And here, if the two are identical, also the interface is a line. So the aim now today is to find what is the equation of this line also. And here, in the third case, sigma 1 and sigma 2 are different. Look, for example, here.
Can I ask a question?
Let me finish this, the part C, and then when I will start the resolution. Okay, just 1 minute. Look, the sigma 1 is 4, 2, 1. That's mean here. Here is something like that. The data in R3, but in R2 is different. It's 4, 1 over 4 here, and 1 over 2, 1 over 2. That means it is small it is small in the direction of x3. It's small in the direction of x3. Very, very huge. That means something like that. Okay, something like that. Okay, something like that, because here it is only 1/4 and here 1/2. Okay, so you can see that the interface will be something like that. Okay, and here we have seen all of this here. Look, in the class, when I explained to you last time the presentation, look, when we go the multi-dimensional case, here if we take the multi-dimensional case, we have seen that if sigma 1 equals sigma 2 equal I, the interface is linear according to the distance between the any point and the average, and the data are circular like that. And if the data if sigma 1 equals sigma 2 equal I, also we will obtain an interface linear like that between the data. And when sigma 1 and sigma 2 are different, we will have different kind of surface like that, or like that, or like that. Okay, so this is what we want to do today, but using numerical application. Okay, I have no, I didn't do any solution, just I wanted to give the classification test. I explained to you what are the kind of the data. Here's the solution. Okay, here's the solution. We start, here's the solution, and we will go for do to the solution. Yes, ask me question.
Yeah, I had the question that you explained already. Why we had question was why we had since we have three-dimensional space, why we have line but not plane for classification?
Yes, I will show you in the calculation. Okay.
Yeah, okay, okay.
Yes, look, I will show you in the calculation now. Look, in the calculation, look, I will put sigma 1 equal, I will take the from the beginning. Okay, I will look what I want today. Here is the solution. What I did, just an explanation according to the course. Look what I want to to say. I will take the part A. Okay, part A. I will eliminate all of this now. Okay, all of this I will eliminate. I don't want to put anything here. And also here. Okay, I want to eliminate everything. Okay. Look, now I want to start the solution. After all the explanation, okay, I will start the solution. Let's go. I will take the part A. Sigma equals sigma equals A. Okay. Look what is in the class here. In the class here, we have this equation. This is the general equation. When you have the general case, you have this equation. You have this equation. This equation. You have to take this equation. Okay. The ratio class 2 over class 1. If it's less than this class 1 over the class 2, so all you have to take all this equation. But we have here some, if sigma 1 equals sigma 2 equal I. So you have, this is the general equation. Here you change, here over here is 1. So you have to take only this and this. So how can we do that? And if there is the same probability, you have to take only this. Let's go to the course. And look, he takes this. He says that sigma, look, sigma 1 equals sigma 2 equal I. So sigma 1 as absolute value is 1, not absolute value, the determinant is 1, and sigma 2 is 1. And what is x? X is x1, x2, x3, because x is R3, and M1 is 1, 1, 1, and M2 is 5, 5, 5. Okay, here mu2 is 5, 5, 5, mu1 is 1, 1, 1, and x here is x1, x2, x3. Why? Because x is in R3. He told me here that x is in R3. Okay, so x equals x1, x2, x3, M1, M1, 1, 5, 5, 5. The probability P omega 1 is 150 over 0.5, so P omega t equals 0.5. Okay, so I know the equations, so I can put every time in its term. So I have this equation. So here is 1 and 1, so it's 0. This one is 1 and 0, so it's 0. So this one is 0, this one is 0, this one is 0. So I have this, and I have this. I can't apply this equation. Okay, I can apply this equation: x minus mu1 transpose x minus mu1 if it is then class 1 equals class 2. What is x minus mu1 transpose x minus mu1? What is this equation? X minus mu1 transpose is x1 minus 1, x2 minus 1, x2 minus 1, because x, look, this minus this minus this is x1 minus 1, x2 minus 1, but transpose will be on the same row, not on the same column, because it's transpose. Same row multiplied by x minus mu1 is the same column. So what is this? The distance. Look, it's the distance. X1 is 1 square, x1 minus 2 minus x2 minus 1, x2 minus 1. So x1 minus 1 square, x2 minus 1 square, x3 minus 1 square. If it is less than, greater than, look, less than, greater than, this one's the same. X1 minus 5 square, x2 minus 5 square, x3 minus 5. Okay? You develop what is x1 square, x2 square, x3 square, and you have x1 square, x2 square, x3 square. You can simplify by all the square here, and you will have minus 2x1, minus 2x2, minus 2x3, plus 1, plus 1, plus 1, plus 3. If it is less than or greater than, of minus 10x1, minus 10x2, minus 10x3. And at the end, look at the end, 10x1, 8x2 is less than 92. At the end, look what I have. Simplify by 8, x1 plus x2 plus 3. If it is less than 9, class 1, otherwise class 2. What do you think of this? What do you think of this? This is a plane. Okay,
Yeah.
look. This is, look. So here is the center. Here is the center 1, 1, 1. The data around is like that. Here are the data 5, 5, 5. The data is like that. The interface is plane, linear. Okay? You understand? I answered your question. You see here. So for any new point, look, for any new point coming here, for example, a new point. For this point, you have x1, x1, yes, x1 here. You have x2 and x3. For any new point, you have x1. If x1 plus x2 plus x3 is less than 9, you have to say class 1. Otherwise, you have to say class 2. Okay? If here, for any point, you have x1, x2, x3. For any new point coming, you have to put it here. Okay, in the neural network, you apply a very big neural network to classify. No, here no. Here you will have an equation for the classification. Okay, you have an equation because this is parametric classification. So we need the parametric data. So for any point, any new point coming here or coming here or coming here or coming anywhere or coming here, you have to put what? You have to put, if x1 plus x2 plus is less than 9, you have to say class 1. Otherwise, you have to say class 2. Okay?
Yeah. It's fine.
Great. Now, I will take the second case. The second case, what is it? What is the second case? Second case is here. The second case is B. 1 sigma 1 equals sigma 2 equal 4, 2, 1, 0, 0, 0, 0, 0, 0. Okay? Yeah. So if this one equals this one, look, that is like that. Okay, like that, not circular like that, but it will be interface. We will see why. Because we have to take the same. Look, in the class here, no, here in the class we have seen that if sigma 1 equals sigma 2 equals sigma, you have to use these slides. Okay, you can copy this slide and you can use the final equation. But you have to pay attention that log p omega 1 omega 2 equal 0. Okay, otherwise you have to put it here. The development of all of these will give you all of these. Okay, the development of all of these, 1 sigma 1 equals sigma 2 equals sigma will give you all. That means will give you this minus this. But you have to pay attention that if you have p omega 1 different of p omega 2, here you will not will be 0. So here you have to put value, 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 and plus value here. Okay, so I will go to the MATLAB here, and I will see. I will see if look, this is the equation, so the same. Okay, I have really this one and this one 0, so I have the same, the same, the same. I have this, so I have to apply only this equation because it is the easiest one. If we apply it, let's go. Look, 2, 2, 2 is 2. X t that means one row. X1, x2, x3. Sigma minus 1. What is sigma? Look, sigma. This is sigma. So what is sigma minus 1? 1 over 4. 1 over 2, 1. 1 over 4 over 2, 1. What is the mu2 minus mu1 is 444 because the mu2 is 555, 111, so it's 444. Okay, look. Mu2 is 111, 555, 5 minus 1 is 4. Great. 444. If it is less than or greater than of mu2 sigma minus 1, mu2 is 5, 1 over 4, 5, minus mu1 transpose. This is mu1 transpose, sigma minus 1, mu1 transpose. If you develop everything, it's very easy. Look, you will have 2. You multiply this times this, you will have, look, this times this, you have 1, 2, 4. 1 to the vector 1 to 4 multiplied by x1, x2, x3, you will have 1x1, 2x2, 4x3. This times this will give you this times 2. Less than or greater than. What is the value of here? Here, 25 over 4 plus 25 over 2 plus 25. 25 over, see? And here, 1 over 4 plus 1 over 2 plus 1 minus. Look, if you continue, constant, and here is a line. You have ax1 plus bx2 plus x3 equal constant. Okay, this is a line. This is a plane. So you see, so if the two axes are identical, here is 111. Here is 111. Here is 111. Here is sorry. Here 111. 555. The interface between both is what? Is a plane. Okay? Is also a plane. Always is a plane. Okay? You understand? Now, look. We will take the general case. C, the part C. If you have general case, sigma 1 and sigma 2, two different. So we have to take, look here. Here we have to start from the beginning. Not here. We have to start really from the beginning. That's mean here. Here. If you have this over this, you have is the general equation here. You have to start from here. Okay? You have to start from here. From this general equation. Like here, when we have different, as I said here, you have to start from the beginning. Okay, from here. If you start from the beginning, what you have? Okay, general case, sigma 1 equals sigma 2 equal, no, C. Sigma 1 equal 4 to 2 and 2 to 4. Look here, I plotted for the class 1, it is the biggest axis is around 1, around 1. It's not like that. The big along 3, along 3 exactly. And for this, the biggest one along 1 or 2. You see, like that and like that. If you have different kind of distribution, so you have something like that. We will see how. Look, you have to start from this. If this one equals this one, you have to have this one. You have to put every term in its value. Look, what is x minus mu2 transpose? x1 minus 5, x2 minus 5, x3 minus 5. You see? What is sigma 2 minus 1? Sigma 2 here, sigma 2. Here, sigma 2. 2 to 4, 1 over 2, 1 over 4. 1 over 2, 1 over 2, 1 over 4. And sigma x minus mu2 not to transpose, so it will be one row, one column. X1 is 2, 5, x1 is 5, x2 minus 5. Plus. Here you have minus. Here you have minus. Exactly. Plus 1 over 2. X1 minus 1, x2 minus 1, x3 minus 1. Multiplied 1 over 4, 1 over 2, 1. 1 over 4, 1 over 2, 1. X1 minus 1, x2 minus 1, x3 minus 1. Okay? If this plus this less than 0.5 times log sigma 2. What is sigma 2? What is the determinant of this? 2 times 2 times 4. And this 4 times 2 times 1. Okay, 2 to 4, 2 to 1. Okay, we develop. If you develop, look what you have. Minus 0.5. Here, this one squared over 2. Look, this one squared over 2. This one squared over 2. This one squared over 4. And the other part, minus this plus this. Look, x1 squared over 4. X2 squared over 2, x squared over 1, less than 0. Look, if you develop, I didn't develop this. If you develop it, look, the x1 square here is over 2, but here is over 4. So I will have x1 square, and you have x2 square, and x3 square, and x1, and x2, and x3 constant. What is this kind of equation? Sometimes it's a circle, sometimes it's a paraboloid. So you have something like that.
Mhm.
Okay? You understand? So it's very, really, very, very important. And now I think that this is all of the course. If you understand this, really, you understand everything. Okay? This is very good question to tell you that the interface has an equation. The interface has an equation, not like neural network. It's not blend. The neural network is a blind classification. Here, no, here, really, if you have for any point coming here, for example, you have for x1, x2, x3, x3. So you will know is class 1 or class 2. So you put it here. Put the data here. Okay, you put the data here. If it is less than this constant, you can say class 1 or class, or you put it here, or you put it here. In general, look, in MATLAB, in Python, we program this, the general equation. We put it here, and here, and here, okay? Because sometimes it's in R38. We didn't plot anything here. Here we can plot in R3 only. In R2, okay, in R3, but in R4 you cannot plot. In R4, you have to pay. You have x1 square, x2 square, x3 square, x4, x4 square, and so on. Okay, and here in this case you have x1, x2, x3, x4 if it's an R4, but you cannot plot. Okay. Tell me if you have any question. Yeah. I'm waiting your question. You understand what is the aim of this? It's really very important, and you will see in the lab today, in the next session, you will see that it is really very easy, and it is a very good kind of classification.
I have a question. It's more
Yeah.
about that. What is the is it a common case that in practice that we have parametric distribution and we know a probability a priori?
Yeah.
Is it
Uh,
common hand with practice and
yeah.
where?
Exactly. Look, in practice, look, you will see it later. In practice, you say CLF equal Gaussian MB. You see what this means? This means that you suppose that your data are Gaussian, like that. That's what this means. What this mean in practice? Very good question. In practice, in practice, I will add a new slide because I will keep the explanation. Look, in practice, someone give you x, which is x1, x2. I will explain the x1, x2 to just to be. You have only two vector, okay?
Mhm.
Two in R2. So you have data here for the first data and second data, and for every point you have y. 0, 1, 0, 1, 1, 1, 0, 1. You see the class. You have x and you have y. Okay, always you have that. Okay, in Python or anywhere. That's mean you can plot it like that. Here are the data of the class 1, because if you choose only the 0 or choose only the 1, you will have point here, point. Okay, the scatter plot. Okay, scatter plot give you something like that, and something like that. I imagine we use that then. Okay, so you can at any time. So what do if you want to say that I want to suppose that these class are parametric? What you have to do? Yeah, directly separate x1 correspond to the class 1, all of y equal 0, and x2 for the class all of y equal 1. You separate this data and this data. You separate. Okay? Okay, great. So what you have to do directly, what you have to do, you have to quickly calculate here x1 and here x2 for the class 1, and here x1 and here x2 for the class 2. So imagine that here you have n1 term, and here you have n2 term. So directly you can estimate p omega 1. P omega 1 equal n1 over n1 plus n2 directly. Okay? And directly you can estimate p omega 2 equal n2 over n1 plus n2. Then what you have to do? How can we estimate mu1? Directly you calculate the mean here and the mean here, so you can have mu1. So from this you can have mu equal mu1 and mu2. Okay, mu1 mu2, which is what the mean here. The average here is mu1. The average here is mu2. So the mu1 is mu11 mu21 mu11 mu21. Okay, and here you can estimate the average here is mu221 and the mu22. You can estimate here for mu2, which is mu21 mu22. What that means? You have the mean one. They have the mean. That means you have the mean here, and you have the mean here. Here is mu1, and here is mu1, and here is mu2. Great. What we I have a mu1, I have a mu2, I have the omega 1, I have the omega 2. What I need also sigma 1. How can I have sigma? So you know that sigma. What is sigma? Sigma equal sigma 1 square cov sigma cov here covariance, and here sigma 2 square. How can we get it from this data here? See, the variance here, I put it here. The variance here in the class 1, I put it here, sigma 1 for the class 1. And the covariance between this and this, I can calculate the covariance between this and this. I can put it here and here. So I can calculate sigma 1. And sigma 2 is what? Is the covariance matrix of this. That means what? That means sigma 1 square, sigma cov, but for the class 2, sigma 2 square, and then, so I can estimate sigma 2. You have sigma 1, you have sigma 2, you have mu1, you have mu2, you have p1, 2, so you have all the data to apply what? You have all the data to apply what? To apply the parametric classification.
Yeah, I got
Okay?
you. Yeah, thanks.
Okay, look here, for example. Here, if you have, look, here's the general equation. What do you, no, not here, for example. General is here. The best general. You need mu2, sigma 2, mu2, mu1, sigma 1, mu1, and the p omega 2. You see? If you have p omega 1, p omega 2, mu1, and sigma 1 and sigma 2, you can apply. For any new point, you can apply in which class it belong. So here I explain to you how can I for each class estimate the covariance matrix and the probabilities and the mean. So look, you will see in Python, it's only one instruction, do everything. This instruction, do everything. When you say fit X-ray, he will take X-ray, he will divide in according to Y-train. He will estimate x1 and x2, mu1 and mu2. He will apply the equation. He will do everything, and then what you have to do directly, you can say predict. For any new point, he applies the equation. You see, these three instructions do everything. Okay? You understand?
Yes.
Yes, and look, you will see that the classifier will give you the p omega 1 and the p omega 2. He will give you how many points we have in class 1, how many points in class 2, what are the covariance matrix, what are the mean. You see? So he will give you everything. You can print everything, okay? You can print everything, and then you can test, and then you can calculate the conversion matrix. You can take all the grid, like exactly like everywhere. Okay, so you have so it's very easy and really very important, and you will see that in this kind of classification like a game. Okay, great. I finished this part. Please tell me if you have any question. Okay. What I want to do, look.
So the classification test, which we have to give, is the formula for the interface. Yeah.
Yeah, exactly. Give the classification test mean give me the interface. Exactly that. I want to homework, Control C. I will copy it at the end of this exercise. And I will put it homework. Not 3, homework. Please imagine that it is around 000 and 444 and R3. I have 1000, 400 in the class 1 and 600 in the class. Okay.
Yeah,
My
make it
question is,
more interesting.
okay. My question is, give the classification test in the 3 cases. I will keep the same. I will keep the same that. Okay. Yes,
Yeah.
I changed 444 or 444. It's better. I changed that I have P omega 1 and I have P are different. Okay. What will change in the program? Okay. His homework. Okay. Please do it and upload it in here in the file. Homework 1. You have to, all of you, upload the file here. Look why? Because you did an exam. Pay attention. You did an exam. Okay, no one changed the date. Okay, great. You did the exam, but the problem is you. I noticed when I correct the exam that all of you, most of you, not most of you, 70% of you use ChatGPT, and they copy what ChatGPT give and they put in the Word. And this is not good because ChatGPT didn't know how I teach you to make the interface, for example. So you copy, you put, and you forget to answer the question as I ask to. It's really strange. 70% of the class do that. It's not good at all. Okay, so I don't want to take only this note. Okay, I will put zeros for all the people who copy from ChatGPT. Please, you have to help yourself by doing the homeworks and upload the homeworks here in the upload the homework here in uh, in the file here. Okay, I don't think that GPT, if you copy all of these, I don't think that GPT will do the solution. I will see.
We already tried. It's not working.
Okay, great. Okay, look, ChatGPT give you don't have to copy and to put it directly in the class. Okay, okay, I'm happy. So you have to do the solution like I did here. Okay, exactly like I did here. Just copy this, put every term here. You have to put just here. You have to put here. It's not zero. You will have zero, some constant. Always. So here it will not be 9, it will be something else. And here also you have to put this term is not 0. You have to put it here, add here. And here also, here you have to start from here. It's easy. It's very, very easy. You can copy also the solve. I change here. I change the data here. Okay. I, I I will give you the same matrix because I don't have time to write another matrix, but you have. Please do this. Do this and put the result where in the in the in the
Sorry.
homework one file.
Yeah.
Okay, before Monday, no problem. Okay, before Monday morning. Okay,
Okay. Okay.
yeah. I will continue. I will continue this here. The last question. Yes, the last exercise. Okay, let us consider two classes of signals: normal class and abnormal class. The spectral density of the first class is Gaussian. Look, the spectral density. It is not related to anything of this. Okay, look. It is not the machine learning. Okay, this one I will delete. It is not machine learning. Okay, I will delete it, and this one also. Okay, no problem. I will go now. Look, I will go now to the class here. Save. Yes. Second exercise is here. Look, second exercise is here. Is in the presentation. Okay, exercise 2. What's happened? Uh, don't tell me that this is an image. Okay. Strange. Okay, it's an image. Okay, no problem. Remember that in the class you have this. You have we want to classify between two Gaussian the same, but here it is an R2. Okay, two Gaussian classes of center M1 and M2. Mi is belonging to the class 2 this time. We have 1000 learning element in the class 1 and 500 in the class 2. Give the classification test the same, but here with rejection. Pay attention. With rejection. Okay, and CR equals 0, 1. You have the same 3 cases. The case 1 is sigma 1 equals sigma 2 equal I, and the second cases is sigma 1 equals sigma 2 1 over 4, and third cases sigma 1 and sigma 2 are different. Okay, I will start. Remember before I demonstrated to you that if you have different classes, if you have different you have to if you have different class you have to make the if you have only two class, you have to calculate R alpha 0 over X, R alpha 1 over X, R alpha 2 over X. You have to calculate the R, and X will belong to the minimum of R. What is R alpha 0 over X, which is the cost? Pay attention, I will use it in the lab. R alpha 0 is CR, and R alpha 1 is 1 minus P omega 1, R alpha 2 is 1 minus P omega 2, and so on. Okay, so R alpha 0, R alpha 1, R alpha 2. So, and X will belong to the minimum of R. In the programming, we will do that. We calculate R, and we will see where is the minimum. Okay, it's very, very easy. So X, but in case of two classes, we have seen that it is easy to demonstrate that if you have to use this liquid ratio, if it is less than CR of minus over CR, this is class 1, and for class 2, it is greater than another threshold. Why we have two thresholds? Because between the two thresholds, the class I don't know. Okay, so here we have seen that in general, if you have with the rejection, if you have many classes, you have px omega 1, px omega 2, you have p omega p omega 2, so you have to calculate r alpha 0, which is the r alpha 1, r alpha m, and x will belong to the class where r is minimum. So I would like to take the case of two class. Please pay attention. Look, for example, with rejection, so I don't have to use. I cannot use the equation of without CR. You have to use this equation. So look, with rejection, you have to use this equation. Okay, this over this is less than this class 1, and this over this if it's greater than this one class 2. Okay, this is the equation when we have rejection. So you will have one line, two lines. This is less than this line, greater than this line, and between the two lines, you have to say I don't know. Let's go. P omega equals P omega 0.5. Okay, this is the equation of the class 2, the equation of the class 2, and here's the equation of what CR over minus P omega 2. What is CR? CR is 0.1. So here you have 0.1 over 0.9. 0.1 over 0.9. Here is equal. So if it is less than class 1. Okay, here is the Gaussian. Here is the Gaussian. You can simplify this and this. So look, I had this plus this less than log 1 over 9. You see? You have a constant coming from this here. So if you develop x is equal to x2, mu2 is 0, 0, mu1 is 8, 8. So minus 0, 5, minus 0, 5, x minus mu2 transpose x minus mu2, this one, and 0, 5, x minus mu1 transpose the distance to class 1, less than minus 0, 5. If you develop, look, you have x1 plus x2 is greater than 8 plus log 9. This is the equation. This is the equation equal 8, and this is 8 plus log. Look, this is the equation equal 8, here 8, and here 8. Equation equal 8, x1 plus x2 equal 8, and here what is 8 plus something, 8 plus something. We continue. For the class 2, no, for the class 2, you have to take greater than this over this. So 0.9 over 0.1. 1 minus 0.1 is 0.9 over 0.1. So you have to put this equation. If you develop, you will have x1 plus x2 less than 9, 8 minus log. Look, 8, this equal 8 minus log. So this one. So you have two equations. If it's greater than this equation, class 1, less than this equation, class 2, and between the both line is I don't know. Okay? Look, between the both line, it is I don't know. So so this is what so this is very important according to CR. If CR is only 0.1, so you have this margin. But if you have 0.001, for example, the margin will be bigger. This margin will be bigger if CR is very high. And at the same time, now solution B, case B, sigma 1 equals sigma 2 equal 1 over 4. Okay? Not 1 over 4, 1. What this means? This means the equation is 4 1 over 4 along class 2, the small, and 1 along class 1. So it's something like that. So the interface will be linear. Also, why? Because if you apply this, and this for the class 1, you have this over this less than the same equation, exactly the same equation, but sigma here will change. Sigma here will change. Okay. So here you have minus 0.5 x minus mu2 transpose sigma 2 minus 1 x minus 2 plus 0.5. Look here, because here is the same, so we can simplify here. Less than 0.9. If you put x2 0.88, you will have something like that. Ax1 plus bx2 greater than a threshold. Okay, x1 and x2, because here you have x1 square, here you have x1 square, here is minus, here plus, so you will not have x1 square, but you will have another line. Okay, another line, and here is the same. If you put this and this at the term, so you will have all this data greater than log 9, so you will have another line. Okay, so here you can have another line here and another line here, and between you will have class 0, and here class 1, and here class 2. Okay, we continue. If the sigma 1 and sigma 2 are different, you have to apply the same equation. Here is equal. Here you put sigma 1 and sigma 2 different. So here you have sigma 1 and sigma 2. Okay. Look, here you have two terms: the log 9 and the probability. The log 9, which is the sigma 2 over sigma 1, and you have the CR over CR. Okay, because here you cannot simplify sigma 2 as sigma 1, so we'll have something like that here. So here, if you continue, you have two lines. Look, you have AX1, BX2, threshold 2, and threshold 1. So you have something like that between both class 2 and here class 1, and here class 1, and here class 2, and here between you have I don't know. Okay, you understand? So really, really is very important if you can do that. Okay, so what I want to tell you now, if you here in the class, in the homework, part 1, do that. Part 2, do the same classification, but if we introduce the rejection with CR equal 0.1. You have to do the same thing, okay? The same of part 1, the same of the part 1, okay, B. So the same, exactly the same calculation, but instead of having M1 for this part 1, we have to use this equation. Okay, for here you have to use this equation, Control C. Here you have to use this equation, okay, for the first part, because the data are you don't have CR, but here you have to use this equation. The equation, the data coming from here, you have to use this equation and this. I cannot copy here. It's strange. It's an image here, huh? I don't know why it's an image.
Yeah, you can copy an image.
Yes, I wanted to copy this, but look what I want to do. I want to say make something. Okay, I want to copy the screen. Copy screen. What is it? Here. Copy image. Here. Great. Okay. Screenshot. Close screenshot. And here. Look. For this part, you have to use this part. Okay. For this, for the part 2, you have to use this, and for the part 1, you have to use this. Okay. For this one, when you don't have any CR, but if you have CR, you have two equation. You understand?
Yes.
It's not hard.
Great. So please do the solution of this homework from the beginning to the end. Try to find the final equations, and please upload the your result in here. Okay, here in homework 1. Okay, I will give you 30 minutes break, and then we will come back to do the programming of this lab. Okay.
Okay. Thank you.
Okay, see you later.